everybody, it's Tyler here at the Speedway Signature event, checking in. It's Space Pandas 884A coming in out of California, having a phenomenal performance so far as we're filming early in this competition, but a lot of great stuff. Really one of the key aspects is their intake. We'll be diving more into how that works so far, but talking about a lot of great things too, maybe some feature plans they're doing, sensors on the robot, and a lot more to learn from this team. So let's find out more about them coming up here on Bits and Parts. Reese, let's start talking about the intake. You and Charlotte, you're the whole team. You put in so much into this. We were talking earlier that you're a garage team just working out at. I love the whole vibe that goes into it. So let's start talking about your intake, and we'll kind of work our way up through different aspects of this robot.
Yeah, okay. So let's just talk about some random little interesting things about our intake. So first thing you might notice is we have a very steep intake. I think it's like 50 degrees or something. So, what that allows us to do is shrink our robot down a lot. So it's very short in length. And what that allows us to do is not only make our robot more maneuverable since it's smaller, but we're also able to add in a lot of other important functions. So we have our wall seg mechanism, and since our robot is so short, during our autons, we're able to start off with scoring on the outline stake within the first second of autons. And that's because our robot is short enough that our outline stake mechanism is able to fit within size. So that's a very big strategical advantage for us. And some other ways that we shrink our robot, just to briefly go over, we have our drivetrain at the shortest possible. I think it's 25 long with just the C channel, and then plus this funnel maybe 28 long. So that's some other ways we make our robot lighter and more maneuverable. And then some other interesting parts, because our intake ramp is so steep, we used to have issues with dead zones at the bottom of our intake when we were trying to get a ring up. So what we did is we added these additional 2 sets of wheels on our intake sled. And what that does is, with the combined force of these upper flex wheels and the lower ones, we're able to pull the ring up more effectively. And then another really unique part, we have a lower tier that can actually lift all the way up. What we use this for one right now, is when we're doing autons, sometimes we want to be able to get that top ring on the stack, and we're able to lift our intake and just grab that top one. And then actually, the other thing that we use this lift for is we're actually planning on implementing a 3-tier climb. So what this does is when we're climbing, we're able to lift it up, and that way our robot can press more flat against the ladder, basically. And if you want to go more into that, actually.
So, adding on, about the intake, another really cool aspect of our intake is actually at the very top. We can see right here in our intake. Our intake, it may be a roller intake, but we still have a color sorter. So at the very top, you can see, we can actually get a zoom in of the polycarb right here, but our ramp at the very top is double layered. There's 2 pieces of polycarb, and it's holding in this one piece of polycarb in the middle, and that's powered by a piston. And essentially, whenever we detect our opponent's color coming in through the intake, we can activate this portion of our robot, and then it'll color sort, and so it'll essentially elongate the ramp so it goes straight over the goal. We can actually intake an opponent's ring right now. Here, Reese, if you want to push the blue ring in. No, just push, yeah. You can see how the polycarb activated, right? That's how we color sort. And then moving on, something else that's really special in my opinion is how we use the polycarb. So you can see our doinker, there's no C channel or L channel on our doinker at all. So the entire structural support of our doinker, or whatever you want to call this, hood, I guess, is entirely made of polycarb. And this keeps it lightweight and very efficient and small and compact, so we don't waste as much space up in there.
Did you have any challenges with using polycarb for structural elements, like that as you're experimenting with it, or any advice maybe for teams who might want to try doing something like that?
Yeah, of course. So polycarb, it's really difficult to get accurate, right? And so what we do is, or what we find works a lot of the time, is that you can actually get a piece of graph paper, and each graph paper or each square on our graph paper is half an inch, I think? No, a quarter of an inch. And what you can do is that you can scale and draw pieces on the polycarb. And what you do is you can line up the polycarb and you can kind of trace out a shape. And then from there, it's really easy to hand cut from there because especially because we don't have a lot of laser cutters in our garage. We have the hand snippers. And so it's really accurate if you line it up with the graph paper.
I think you just made hole counting for polycarb.
Oh, yeah.
Pretty much, so.
Yeah.
No, that's really cool. Looking at your robot, we talked about looking at doing a level 3 climb in the future as well. Any other feature improvements you might look at doing?
Yeah. So I know like we talked a little bit about the level 3 climb, but essentially what we also want to try and do is we want to make our robot like shorter as well, because we want to implement either like a passive level 1 hang or a really cool like 10-second level 3 hang. But our robot is like a little bit taller. It's like under the first tier, so it's not really easy to activate something to hook on at the very top, because like we're essentially a little too close. So I do want to focus on like maybe compacting our robot even more, even though we're at like the minimum length right now. I want to focus more on the height.
You have a bunch of sensors on your robot. Are there a couple key ones you want to point out and how they're functioning?
Yeah, so we mentioned how we have color sorting on our robot earlier. So how we do that is on our intake ramp, we have 2 optical sensors, if you want to point them out. We just have 2 for redundancy. So when we're intaking a ring up, we're able to detect what color it is. And so sometimes we have discrepancies between the 2. And so what we do is we just take the data that we get from the top one, because it's the most recent. And so that's, allows us to decide whether or not we want to trigger this color sorter. And then
in fact, we can try holding up an opponent's colored ring, and then you can see when here. If you want to lift up the hood for me, the intake one, and we can shove it in. You can see when it hits the optical sensor, that's what extends our ramp. If we take it out, it'll retract just like that. And another really cool sensor maybe I want to go into is our AI sensor. So most teams might think, oh, that's a really interesting place to put it, right? And then, well, for our AI sensor, we actually find in skills especially, it's really useful for sensing the wall stakes. And then what this does is essentially we can track the color of the wall stake, right? Especially since the cap is yellow, and then the line stake on the other side is blue, and they're colors that we can really easily see against a darker background. And so we have an offset, right? We can code in an offset into our AI auto aim, but this allows us to be a lot more consistent with wall stakes, especially if we get off later in the run, and then we want to just, recorrect a little bit.
So I just want to talk about polycarb again. So you'll notice that we actually use polycarb on a lot of our structural aspects. That's something that you don't see too often, but we find that, it's very hard for polycarb to shatter, and it's also very lightweight. So we're able to replace a lot of metal by, using polycarb for structure. And on areas like our intake, we have almost entirely polycarb. So we know that this doesn't require a whole lot of super, strong structure. So we're like, why don't we, try to minimize our weight? We take advantage of that. So this is all polycarb for each parts of our intake.
Just to reiterate what we said, you can see our whole arm is polycarb. This has a lot of give, especially since when you ram into the corner, you when we previously had C-channel arms, they bent a lot. But what's really nice about our polycarb arms is I can shake it as much as I want, and it'll always go back to the same spot. So it has a lot of give essentially, and then I think that's what we're looking for, because it's a lot more robust too. And then last thing, for all the teams who are kind of looking at intakes and the polycarb, one really cool thing that you can do is you can sand down the polycarb, and it allows for a smoother intake because it's less friction. So yeah, it was a cool little thing.
Yeah, I love all the detail and thought process that's gone into it. 884A Space Pandas, once again, thank you so much for taking time. Lots, I think teams can learn from this, so that's awesome stuff to showcase the community. Best of luck here at Speedway as well. Can't wait to see how you do it. Good luck the rest of the way. Thanks a lot.
Thank you.